In this video, I will show how to evaluate an improper integral of a rational function with one of the limits of integration being an infinity. First, we have to acknowledge the fact that one of the limits is infinity, and then also check that there are no other issues with this integral on the interval of integration. That is, we want to check whether this function is continuous on the entire interval of integration. So let's factor out the denominator. So we have a rational function with the denominator x plus 4, x times x plus 1. So the discontinuities of this function occur at -1 and -4. Therefore, we don't have any other issues with this integral other than infinity. So to fix that issue, we're going to introduce a variable t, and we're going to set it up as a limit as t goes to infinity. Now, in order for us to integrate this rational function, we have to decompose it using the partial fraction decomposition method. So let's do that over here. So by partial fraction decomposition, we are going to look for the decomposition in this form, and rewriting everything as a single fraction gives us the following expression, and distributing everything and collecting the like terms. All that must be equal to 1 over x plus 4 x plus 1. That means that the coefficient of x is 0, that is a plus b is 0, and the free coefficient a plus 4b equals to 1. So that gives us a system of two equations in two variables, which we can easily solve by subtracting one equation from another and finding a and b. So the integrand therefore can be rewritten as 1/3 x plus 1 minus 1/3 x plus 4 dx. Now we are going to integrate the function. It's going to be 1/3 ln of x plus 1 minus 1/3 ln of x plus 4, and we will be evaluating this between 0 and t. Before we evaluate it, I'm going to simplify it using the properties of logarithms, and I'm going to rewrite it as 1/3, which can actually be factored outside of the entire limit. And what's left inside is the difference of logs, which can be written as the logarithm of the ratio. So what we actually have here is natural log of x plus 1 over x plus 4, and we now evaluate it between 0 and t. So at t, we have ln of t plus 1 over t plus 4 minus ln, and now we're plugging in 0. So at 0 is just 1/4. Now finding this limit as t goes to infinity, we first have to identify ln as continuous function, so we can switch ln and the limit, so we can take natural log of the limit as t goes to infinity, t plus 1 over t plus 4, and ln of 1/4 is actually just a constant, so it doesn't have to be part of the limit, and limit of that ratio is 1 because it's just a rational function, and leading terms are exactly the same. So we have actually found the answer. So the integral converges, and it converges to this expression. Ln of 1 is 0, and ln of 4 can be rewritten as, negative ln of 1/4 can be rewritten as ln of 4. So this is the final answer.